Okay, here we go. As you open up the back page, today we're going to talk about exponential functions, and an exponential function has this form. Y is equal to some number to the x power. An example would be, say, y is equal to 2 to the x. Now, what we want to start by doing is investigating what y equals 2 to the x looks like, or what a parent function would be for an exponential function. And so I'm going to take out my calculator. We're going to look at some table values so we can investigate what's going on. Wrong class. 2 to the x. And I'm going to go to my table, and I'm going to type in values of 0, 1, 2, 3, 4, 5, 6. Okay? And first of all, anything to the 0 power is 1. So it passes through 0, 1. Second of all, what do you notice is happening to the y values? They're getting ridiculously large, right? And they're going up, they're doubling every time, right? Which is not a surprise because it's y equals 2 to the x. However, the fact is they're getting ridiculously large. So as I go to the right side, you can see that the graph is going up. But now let's look off to the left-hand side. So I'll type in values that would bring it to the left. So like -1, -2, -3, -4, -5, -6. What's happening to those values? Yeah, in fact, they're getting ridiculously small. How come? Two to the -7th is the same as what? 1 over 2 to the 7th, right? So that means the denominator is becoming extremely large, which means if the denominator is becoming extremely large, then the whole number is becoming extremely small. But it is still positive. I mean, I could change this, and I could type in -12, and, well, let's try to do something without an e value. So you can see if I go -9th, okay, even smaller, but it's still positive. So the deal is that the graph stays above the x-axis. And because it approaches the x-axis, we have this thing. What do we call that thing I just drew? An asymptote. A horizontal asymptote has a horizontal asymptote of y is equal to 0. The domain is all real numbers. The range is 0 to infinity. Very good. Does not include the 0. Is everybody okay with that? I'm going to switch it. Right now, my a value is greater than 1, so we had a value of 2. I'm going to switch it so that the a value is less than 1. I'm going to make it a 1/2. So parentheses 1 divided by 2 raised to the x power. And now when I look at my table, well, what do you notice about the negative values now? They're really big. And then the positive values will be really small. And the graph goes like that. How is that graph just like the one that I drew? Reflected over the y-axis, a horizontal reflection, right? Let's see why that is. I have y equals 2 to the x, and we had y is equal to 1/2 to the x. Well, isn't 1/2 the same as 2 to the -1? Well, these graphs would be horizontal reflections of each other, wouldn't they? Very cool. So if you have a number that's less than 1, it creates a horizontal reflection. Still have the asymptote, still have a domain of all real numbers, still have a range from 0 to infinity. Now, we bring up a number that often people say, I don't know what that means. I don't know what it is. Okay, well, how about pi? Okay, but if I say the number pi, you're familiar with it, right? You just treat it like any old number. It's just 3.14, right? The same thing with e. E comes up in nature almost as often as pi does. It's incredible. It makes calculus remarkably easier for a lot of things we do. It's a very, very special number. And so it's y equals 2.718 to the x power. That's what it means. So is that going to look like the first graph or the second graph? It's going to look like the first graph, right? Just crosses through 0, 1. So how about y equals e to the negative x? That will be a horizontal reflection. Go like that. So in terms of order of what we've decided to cover in this class, or I should say the way the book has laid it out as well, is last unit we talked about y is equal to things like, say, x to the third, right? Well, now we're looking at what if we switch those? What if 3 is the base, but x becomes the exponent? So that's the difference between a polynomial and an exponential function. That's what makes those truly different, okay? So a lot of things in life are not polynomials, but rather exponential. Flip to the very front, and let's start our notes. Y equals 4 to the x. Will y equals 4 to the x start down and finish up, or start up and finish down? Start down and finish up. Why? Okay, it is positive, Jackson, but also because 4 is greater than 1. Okay? So I have a domain of all real numbers. I have a range from 0 to infinity. What is my horizontal asymptote? Y equals 0. We have boys basketball in action tonight, don't we? Good luck, Scott. Where you guys play? All right. Always passes through 0, 1. Because anything to the 0 power is 1. X to 5th over x to 5th is the same as x to the 0. And anything divided by itself is, therefore, anything to the 0 power is 1. Right? So if you have y equals 4x, and you plug in 0 for x, 4 to the 0 power is 1. Okay, we look at the next one. How is b going to be different? Why? Very good. So it's still going to cross through that 0, 1. Let's go the other direction. It's a horizontal reflection because it's 4 to the negative x. Domain of all real numbers. Range of 0 to infinity. And y equals 0 is our asymptote. How about C? Is it going to look like letter A or letter B? Why? Because, yep, 2 is greater than 1. Very good. Now, some people say, well, how will it be different? Well, the next point on this graph would be an x value of 1 and a y value of 4, right? Whereas on this one, the next value would be 1 and the y value would be 2. So y equals 4 to the x just gets bigger more quickly. Y equals 2 to the x, same type of shape, just doesn't get big as quickly, okay? We don't need to fill out the rest of it. We'll move on to ones that are a little bit more critical. You guys have the basis. Let's now apply what we've learned about transformations. What makes letter D different? Is the negative on the inside or the outside? It is on the outside. Will that create a vertical flip or a horizontal flip? Vertical flip. So I'm going to draw the parent function. Is everybody okay with that parent function? Great. Then as I glance at this, if I create a vertical flip, instead of passing through the point 0, 1, it will pass through 0, negative 1. Will it change the asymptote at all if I were to flip it? Nope, it doesn't. The domain for an the domain of an exponential function, all real numbers in this situation still. the only way that would change is if, let's say we had y equals 2 to a power, but instead of x, you had it to say the square root of x. Well, then there's certain negative values you couldn't plug in, correct? So we're not going to look at that example. All the examples you look at, all real numbers will be the domain for exponential functions. But the range will be negative infinity to 0. Very good. And the asymptote is still y equals 0. What makes letter E different? Excellent. It does have another number. What does that number do to it? It's on the outside. It creates a vertical shift. So the parent function, I will draw in green. And it is a vertical shift of 4 down. So if the vertical asymptote shifts down 4, what's going to be the new location? The horizontal asymptote is currently going through what? 0. So if it shifts down 4, it will go through negative 4. Now, William, the point that it passed through was 0, 1. So it will now go through 0, negative 3. Domain, all reals. Range, what about the range here? Very good, negative 4 to infinity. The horizontal asymptote, y equals, very good. On YouTube, if I said vertical asymptote at some point, I'm sorry, I mistakenly spoke. So. Okay, the last one. How is this different? Okay, let's look at the parent function. Will the parent function start down and finish up, or start up and finish down? Y will start up and finish down. Very good. So I'm going to cross through this spot right here. That's the parent function. Let's now produce the transformations. What is the transformation that occurs? It is up 1. Right, 2. So let's think about that. Would you like to start with the point or the asymptote? You tell me. Okay, the asymptote. If I move the asymptote right 2, does that change it at all? It doesn't. It's already horizontal, so moving it horizontally doesn't change it. Does the plus 1 change it? Yeah, it moves it up 1 unit, right? So my horizontal asymptote becomes y equals 1. Now, the point, it was at 0, 1. So if it moves right 2 and up 1, what's the new location? Yeah, 2, 2. Very good. What am I doing? Idiot. So it goes through 2, 2. Well, it went through 0, 1, and we said you're going to go up 1, so I'll change the y value to 2. And we said it's going to go right 2, so it's going to move the x value from 0 to 2. Is that better? Leiwa? Okay, and then we said this one's going to start up and finish down. There we go. Okay, so graphing is actually going to be, intertwined in your assignment today. The other piece that you want to be able to do is the quick piece where we identify the actual functions that they produce. These are intended to be easy points on your test. I would say 25% of students get these incorrect, and I do not want that to happen for you. Here's what we want. An exponential function is of the form y equals a to the x, which means you could end up with, say, y equals 2 to the x, or y is equal to 4 to the x, or y is equal to 1/7 to the x, or y is equal to 10 to the x. You know, that's the type of result that we're looking for. Now, as you look at this, it says find the exponential function that passes through the points. These all pass through what point? They all pass through 0, 1. So we have to look at the second point. Well, this is my x value, and this is my y value. So if the x value is 2, and the y value is 25, then we write 25 equals some number a raised to the second power. So what number do you square to get 25? 5. So here's what people write that is incorrect on the test. They write a equals 5. I don't give you the points for that. People write 25 is equal to 5 squared. I don't give you points for that. But when you write y is equal to 5 to the x, then I give you the points, because we are trying to write an equation for an exponential function. This is a function. It's got x and y in it. Those other ones don't. I understand that you knew that a was 5, but I also understand that you don't know what a function is. And I take points off for that. Yes. Oh, excellent question. Okay. So Gigi's question was, as we want to solve for this, why can't we say that a is positive 5 or negative 5? We will not look at situations where a is less than 0. If a is a negative value, that really changes everything about how we do these. If you look at our original kind of assumptions, we said that we're going to make sure that, hey, where am I? Where'd it go? Here it is. We looked at a greater than 1, and we looked at a between 0 and 1. We will not allow a to be less than 0. If a is negative, it doesn't have the same shape or characteristics. And there's just not really many times in the real world where our base is negative. It just doesn't happen. Okay. So we go back. Let's finish these off. Okay. Here I have, this is x and this is y. So 2/3 is equal to some number a to the negative 1 power. What number do you take to the negative 1 power to get 2/3? 3 halves. So if a is 3 halves, then my function is y equals 3 halves raised to the x power. That's what I have. You do have to have it in parentheses, and this is the reason why. If you write 3 halves to the x power, technically that means 3 to the x power divided by 2. So all fractions need to be written in parentheses that way. Okay. So we don't want that. Before I have you do these two problems on your own, really quick, have you noticed it's a little bit odd to think of what number do you raise to that power to get that? You're starting to do what we call logarithmic operations. That's what logarithms do. Logarithms work with bases and exponents, and it can be kind of confusing. Okay, so but we'll take it one step at a time. You do letters C and D on your own. Go. Okay. These answers are as follows. I'm guessing most of you got y is equal to 2x, right? But this part, y equals 1/10 to the x. Notice you could rewrite it as y equals 10 to the negative x. Either or is fine. You could write it with a negative exponent or a positive. It doesn't matter. I just want you to understand those are the same. Both are accepted. We good? Assignment. Go.